everybody?
I don't see anyone.
It's weird. This is the right hotel, right? Oh, it says it went virtual.
Hello, my name is Stefan Muller, and this is Hannah Ringler, and we are presenting our Onward essay entitled A Rhetorical Framework for Programming Language Evaluation. I'm in programming languages, and Hannah is a researcher in rhetoric in an English department. This piece came about from some discussions we were having when we were at Carnegie Mellon about user studies and how we make claims in programming languages research. As we were talking, we realized that rhetoric, as a field, has some interesting ideas for how we might think about claims in PL. So we wanted to share our thinking on that topic. In PL research, we make a variety of different kinds of claims. For example, we might say that an algorithm scales much more gracefully than past work, that a static checker has a simpler annotation language than others, or that a memory model tries to achieve sufficient ease of use. All of those are quotes from actual PL papers. Each of these types of claims requires different kinds of justifications. For example, a claim about type safety would be justified with a proof of progress and preservation, and a claim about scalability would be justified by evaluating it on different size inputs. Some claims don't have explicit justifications, though, and often these go unnoticed until they reach a different audience. For example, at the 1978 History of Programming Languages conference, John Backus called the source language of a particular compiler elegant by comparison with the earlier ones. But this is an algebraic language with no looping construct, and most PL researchers in 2020 wouldn't see this as elegant. Claims of this type about work being elegant, simple, usable, and so forth are evaluative claims, meaning they are referring to properties that the researcher thinks their work has. And as we see with Backus's example, there is often implicit agreement about what these terms mean. The 1978 Hopple community seems to have had a different sense of what elegant means than PL researchers do today. Even more objective sounding claims, like something being type safe or efficient, have had subtle changes over time as well. How do these shifts in meaning occur? In other words, why did Backus's claim about elegance make sense in 1978, but not today? And how can we guard against this kind of shifting in meaning, confusing different or future audiences when they read today's PL papers? In this essay, we suggest a framework that we think PL researchers can use to make subjective claims more convincing, accessible, and stable, by considering the different kinds of evidence appropriate for justifying them. We developed this framework by drawing on argument theory and rhetorical analysis, two fields that are also concerned with the effects of language on audiences, only they study natural languages as opposed to programming languages. So in this talk, we're first going to outline different kinds of claims that are made in PL and the types of evidence currently used to justify them. Then we're going to introduce some concepts from argument theory and rhetorical analysis to explore how they can provide a framework for justifying more subjective types of claims. We'll develop this framework for programming languages and show several examples of how this framework is already being used occasionally in PL research. We'll conclude with a call for increasing justifications of claims in the future, and end with some time for questions. Before discussing how to justify claims made in PL research, we want to describe the sorts of claims we're discussing, since there are many kinds of claims, and each requires different justifications. I should point out that this categorization isn't exhaustive or mutually exclusive, but it's just to give a sense of the different sorts of claims we want to be able to talk about. We build on a listing of claims by Koblenz et al., who identified three broad types of claims made in the development of new programming languages. Formal properties, such as type soundness or other correctness guarantees. Observational properties, such as performance, which relate to the compilation and execution of programs written in the language. And effects on programmers, which covers attributes related to the user experience of programmers using a language, such as usability, ease of reasoning, and modifiability. While Koblenz and his co-authors were mostly interested in the development of programming languages, in our essay, we are considering PL research more broadly, including the development of calculi, algorithms, tools, and so on. So we also identify a fourth category, which is more relevant in papers concerning calculi and other formalisms that aren't really meant to be used directly by end users. Aesthetic properties include those that are related to the human-centered aesthetic appeal of a language or formalism or other technique, but which are not directly concerned with ease of use by others. Examples would include elegant, natural, and intuitive, although this category is perhaps better defined in part by the oft-used antonym of those terms, ad hoc. Generally, formal or category 1 properties are justified with a proof. Observational or category 2 properties are generally justified with quantitative experiments, such as performance evaluations. Many authors justify category 3 claims with user studies. We don't dispute the possible usefulness of user studies, but we also recognize that user studies are subject to the cultural biases of the time and the population in which they're done. As such, these kinds of claims, even when justified with user studies, are more susceptible to the kinds of shifts in meaning that I talked about earlier. Because category 1 and 2 claims are somewhat less susceptible to these shifts, although they still have some degree of subjectivity, as we discussed in the essay, we'll focus on category 3 and 4 claims as we develop a new framework for thinking about evaluating claims. The third and fourth categories of claims, effects on programmers and aesthetic properties, are more evaluative claims and necessarily audience dependent. This makes them tricky to justify in more concrete ways. So to think about a solution to this problem, we draw on rhetoric and communication studies.
That's where I come in. So rhetoric is a field of study about language and the effects that it has in the world, and generally understands language as being incredibly socially and historically contingent. So that is, natural language theorists would explain that all language is constantly shifting in meaning. So as a quick example, take the phrase fake news. So this draws up entirely different images for us now in the kind of Trump era of politics, though we're filming this pre-election day, than it did before 2016. And we might say the same about phrases like family values after the Republican National Convention in 1992, or the term pro-life after it began being applied to abortion rights. So these kinds of shifts in language meaning are theorized well by a language philosopher named Mikhail Bakhtin. So he coined two terms to talk about language contingency. First, he explained that language is dialogic, meaning that words and phrases take meaning and shape at a particular historical moment and in a socially specific environment, and thus are already shot through with meaning from all the ways they've been used before. So for example, when Bacchus used the term elegant to describe an input language in 1978, he did so only having heard all the ways that elegant had been used to describe languages before, which seems to have been applied to different kinds of languages with different kinds of properties than the ones that researchers today will mark as elegant. And when researchers in 2020 use the term elegant to describe a language, their evaluation of what warrants that designation is based on the languages they've seen the term applied to in the past. However, the languages that researchers have heard the term elegant applied to even today will all be slightly different based on the classes the researcher has taken, the other researchers they've collaborated with, the conferences they've attended, and so forth. In this sense, every person will have a slightly different understanding of what it means to be elegant. This gives language a heteroglossic property of having multiple different shades of meaning for the same words or terms, which are socially and historically dependent. So for example, what a PL researcher might think of as a simple language might be different than what an undergrad student learning to code would call a simple language. If the evaluations that researchers use on their work are natural language terms and they have these dialogic and heteroglossic qualities that Bakhtin theorizes about, then what exactly is meant by them is unstable in its dependence on time and community. So that is, claims about a programming language may not hold up in 30 years. And perhaps more importantly, they may not hold up to those in other communities. So we wind up with this ethical problem when evaluative qualities are assessed mostly by those within the academy rather than by those in other communities. So because language has the property of being socially and historically contingent in its meanings, studying the effects of language on people must be grounded in those kinds of contexts. So rhetorical analysis is a broad category of techniques that tries to understand how people influence each other through language, in particular historical and social contexts. It's essentially a method or multiple methods that try to describe how a text achieves certain effects on an audience. In this sense, rhetorical analysis is very descriptive of the text it analyzes, and it grounds that description in the context. For example, a rhetorical analysis might describe how a series of historical events creates a certain exigence for a speech, for example, called a rhetorical situation, much like a mass shooting seems to historically prompt reflective speeches from politicians. Or an analyst might describe how a political memoir uses a lot of first person and narrative language in order to create a more personal identity and relate more to potential voters. In rhetorical analysis, then, evaluative claims about effects on audiences are justified by in-depth descriptions of the strategies that a text uses to create effects for those audiences. So argument theory, which is a sort of subfield of rhetoric and communication studies, offers a framework we can adapt for thinking about how arguments are constructed, wherein argumentative claims are justified with reasons, and then those reasons can be explained with evidence. So when applying this argument framework to rhetorical analysis, argumentative claims about text and what they do, for example, being personal and connecting more to voters, is backed up with reasons in terms of descriptions of the rhetorical strategies they employ. We say this has a lot of first-person or narrative type of language. And that can then be evidenced with descriptions of the context of the audience that link effect and strategy. So justifying claims about effects in this way allows for critical thought about why certain effects are achieved and how, rather than simply stating that the effect was achieved in a particular moment in time.
Back to me. Just as rhetorical analysis uses descriptions of rhetorical strategies that texts use to produce certain effects on readers, we believe that programming languages researchers can describe features of programming languages or tools in order to justify that those features produce certain effects on programmers or users. In the argument theory framework, descriptions of these features would be the reasons to justify the claim. At this point, it would be great if we could give a framework for justifying category 3 and 4 claims in PL papers. But every claim and every paper is different, so we can't just give you a specific blueprint. But we will illustrate how you might apply our ideas in a PL context through some ideas and examples drawn from actual PL papers. We'll follow the same idea of using reasons to support the claims and then connecting the reasons and the claims with evidence. In that vein, I'll talk about reasons first and then evidence. Consider the paper describing the Silk 5 language, which repeatedly highlights the simplicity of the language relative to earlier versions of Silk, saying, for example, the language has been simplified considerably. It employs call and return semantics for parallelism. Now, you might not think that just having call and return semantics is a particularly strong case for a language being simple, but it does stand in contrast to earlier versions of Silk, which required a style similar to continuation passing. The point made here is that in Silk 5, you spawn a thread in the same way you'd call a function in C. They make this comparison to C more explicit later in the paper, saying, the basic Silk language can be understood from an example. Figure 1 shows a Silk program that computes the nth Fibonacci number. Observe that the program would be an ordinary C program if the three keywords silk, spawn, and sync are elided. The semantics of a spawn differs from a C function call only in that the parent can continue to execute in parallel with the child, instead of waiting for the child to complete, as is done in C. This expert follows the basic claims and reasons framework by making a claim about the simplicity of the language and giving reasons for it by emphasizing Silk's similarity to C and giving code example to show that the code is fairly simple and resembles C. Even just giving a code example, which is a common way that authors of PL papers demonstrate claims about new languages, especially claims like simplicity, can be seen as a reason in our framework. You give a code example, like the example in the figure of writing a Fibonacci function in Silk, that you think highlights the features of the language that make it simple, and the reader can agree or disagree. In the case of the Silk 5 authors, they go even further and justify why they think the code example demonstrates simplicity. The code looks like C, and thus implicitly is understandable by audiences familiar with C. That covers claims and reasons. The evidence part of the framework gets slightly trickier in the context of PL. In some cases, if it should be clear to the audience why the reasons justify the claim, evidence might not be necessary. Again, though, this depends on the audience. If your reason that a language is simple is that it's similar to C, this reason will be fine for an audience that thinks C is simple. Maybe the audience of Splash is such an audience. You might get more resistance to this justification from a lay audience, or say at ICFP. When you do decide you need evidence to support reasons, that evidence should focus on the relationships between effects and audiences. If you want evidence that a particular language feature produces a desired effect on programmers, then perhaps an agglomeration of many user studies will demonstrate that this effect is broadly seen. As an alternative, you could rely on studies from psychology of the effects of programming languages on programmers. There's admittedly not a ton of research in this area, but one body of work that does exist there is the cognitive dimensions framework of Green et al. This lays out a number of dimensions along which languages, UIs, tools, and so on can be evaluated for effect on users. Some researchers are even, at least implicitly, relying on these frameworks. Consider this justification that a class of constraint logic programming languages is intuitive. Intuition about reasoning about programs is enhanced as a result of working directly in the intended domain of discourse. This contrasts with working in the Herbrand universe, wherein every semantic object has to be explicitly coded into a Herbrand term, thus enforcing reasoning at a primitive level. Now, it may seem reasonable on its face to claim that a semantics is intuitive because it allows you to use representations that are closer to the semantic objects you have in mind. But if you're looking for more evidence, compare this to the motivation for the closeness of mapping cognitive dimension from Green's framework. Programming requires mapping between a problem world and a program world. The closer the programming world is to the problem world, the easier the problem solving ought to be. For more examples of claims, reasons, and evidence in action and PL, see our essay in the proceedings. In general, there is more work to be done to determine what forms of evidence are useful for justifying certain claims in PL papers, and we hope we've inspired some of you to look for these forms of evidence. Mostly, though, we hope we've given you more of an awareness of the claims you make in your own research, and the ways in which they might be subjective, and inspired you to think about how these claims might be justified. We suggest that explicitly describing how specific features of your work produce the desired effect is one such way, and that it can and should supplement other evaluation methods, such as user studies and other empirical evaluation techniques that may be developed in the future. In particular, we think that the suggestions we presented here are particularly useful for claims like beauty, where there aren't and may never be empirical evaluations to rely on. Thanks for listening.